Spacecraft Discovery, an introduction to spacecraft exploration and survey vehicles. Space exploration has been a topic of fascination for humans for centuries, and over the years, we have made significant progress in our understanding of the universe. With the help of spacecraft, we have been able to explore our solar system and beyond, and uncover some of the mysteries of the cosmos. In this article, we will discuss the various spacecraft used for space exploration and the discoveries they have made. One of the most well-known spacecraft is the Hubble Space Telescope. Launched in 1990, the Hubble has revolutionized our understanding of the universe by capturing high-resolution images of distant galaxies and stars. With its ability to observe the cosmos in visible, ultraviolet, and infrared light, the Hubble has allowed us to study the formation of galaxies, the evolution of stars, and the characteristics of black holes. Another spacecraft that has made significant contributions to space exploration is the Voyager 1 and 2 spacecraft. Launched in 1977, the Voyager missions were designed to study the outer planets of our solar system. During their journey, the spacecraft captured stunning images of Jupiter, Saturn, Uranus, and Neptune, and provided valuable information about the planets' atmospheres, moons, and magnetic fields. Voyager 1 has since become the first man-made object to leave our solar system and enter interstellar space. In addition to the Voyager spacecraft, NASA's Mars rovers, Spirit, Opportunity, and Curiosity have played a crucial role in our exploration of the Red Planet. These rovers have captured images and data that have helped us better understand the geology, climate, and history of Mars. They have also provided evidence that liquid water once existed on the Martian surface, which has led to the possibility of finding microbial life on the planet. Beyond our solar system, the Kepler spacecraft has been instrumental in the discovery of exoplanets, planets outside our solar system. Launched in 2009, the Kepler mission has detected over 2,000 confirmed exoplanets and thousands more potential candidates. These discoveries have led to a better understanding of the prevalence of planets in our galaxy and the potential for extraterrestrial life. Continuing on from the previous section, there are several other spacecraft that have contributed significantly to our understanding of the universe. One of them is the Cassini spacecraft, which was launched in 1997 and entered orbit around Saturn in 2004. Cassini's mission was to study Saturn and its moons, and it provided us with a wealth of information about the planet's atmosphere, rings, and magnetic field. It also discovered several new moons around Saturn, including the intriguing moon Enceladus, which has a subsurface ocean and geysers of water vapor and ice. Another spacecraft that has made significant contributions to space exploration is the New Horizons spacecraft. Launched in 2006, New Horizons flew past Pluto in 2015, becoming the first spacecraft to visit the dwarf planet. The mission provided us with the first high-resolution images of Pluto and its moons, revealing a diverse and fascinating world that was previously unknown to us. The Juno spacecraft is another mission that has increased our knowledge of our solar system. Launched in 2011, Juno arrived at Jupiter in 2016 and has been studying the planet ever since. The spacecraft has provided us with detailed images of Jupiter's atmosphere and magnetic field, and has helped us better understand the planet's interior structure and composition. Finally, the James Webb Space Telescope, set to launch in 2021, is expected to revolutionize our understanding of the cosmos. Designed to observe the universe in infrared light, the telescope will be able to study the formation of galaxies, stars, and planets, and search for signs of life on exoplanets. In addition to the spacecraft mentioned above, there are several other missions that have contributed significantly to our understanding of the universe. One such mission is the Chandra X-ray Observatory, launched in 1999. The observatory was designed to study X-ray emissions from hot gas in the universe, including black holes, neutron stars, and supernova remnants. Chandra has provided us with detailed images of these objects and has helped us better understand the extreme physics that occurs in these environments. The Spitzer Space Telescope is another spacecraft that has made significant contributions to space exploration. Launched in 2003, Spitzer observes the universe in the infrared spectrum, allowing us to study the formation of stars and planets, as well as the evolution of galaxies. The mission has provided us with valuable data on the early universe and has helped us better understand the properties of exoplanets. The Dawn spacecraft is another mission that has increased our knowledge of our solar system. Launched in 2007, Dawn visited two of the largest objects in the asteroid belt, Vesta and Ceres. The spacecraft provided us with detailed images of these objects and helped us better understand their composition and history. Dawn also discovered bright spots on Ceres, which turned out to be deposits of salt, suggesting that the dwarf planet had a subsurface ocean at some point in its history. Finally, the Parker Solar Probe, launched in 2018, is a mission that aims to study the Sun up close. The spacecraft will fly through the Sun's outer atmosphere, or corona, and provide us with valuable data on solar wind, magnetic fields, and other phenomena that affect our planet. Continuing on from the previous section, there are several other spacecraft that have made significant contributions to space exploration and scientific discovery. One such mission is the Kepler Space Telescope's successor, the Transiting Exoplanet Survey Satellite, TESS. Launched in 2018, TESS is surveying the entire sky to identify nearby exoplanets that may be good candidates for follow-up observations. The mission has already discovered several new exoplanets and is expected to find many more in the coming years. Another mission that has increased our understanding of the universe is the Gaia spacecraft. Launched in 2013, Gaia is creating a 3D map of the Milky Way, measuring the positions, distances, and motions of more than 1 billion stars. The mission is expected to provide us with valuable insights into the structure and evolution of our galaxy. The InSight mission is another example of a spacecraft that has contributed to our understanding of the solar system. Launched in 2018, InSight is a lander that is studying the interior of Mars, using instruments to measure the planet's seismic activity, heat flow, and other characteristics. The mission is providing us with valuable information about the formation and evolution of rocky planets like Mars and the Earth. Finally, the OSIRIS-REx mission is a spacecraft that is currently orbiting the asteroid Bennu, with the goal of collecting a sample of the asteroid's surface and returning it to Earth. Launched in 2016, the mission will help us better understand the composition and history of asteroids, which are believed to be remnants from the early solar system. Space exploration has been a topic of fascination for humans for centuries, and with the help of spacecraft, we have been able to explore our solar system and beyond, and uncover some of the mysteries of the cosmos. In this section, we will discuss some of the newer and upcoming spacecraft that are set to make significant contributions to space exploration. One upcoming mission is the Europa Clipper, a spacecraft that will study Jupiter's moon Europa. Europa is believed to have a subsurface ocean of liquid water, making it a prime candidate for the search for extraterrestrial life. The development of the philosophy of religion through the classics of the world. The philosophy of religion is a field of inquiry that has been studied for thousands of years, and its development can be traced through the classics of the world's major religious traditions. From the Vedas of ancient India to the works of St. Augustine in the Christian tradition, the classics of the world have explored the nature of God, the meaning of existence, and the relationship between humanity and the divine. In this article, we will examine the development of the philosophy of religion through the classics of the world. Ancient India, the Vedas and Upanishads. The Vedas are a collection of ancient Hindu texts that were composed between 1500 and 500 BCE. These texts are among the oldest religious texts in the world, and they offer a window into the early development of Hindu philosophy. The Vedas contain hymns, prayers, and rituals that are dedicated to various gods and goddesses, and they explore the nature of existence and the relationship between humanity and the divine. The Upanishads are a group of texts that were composed between 800 and 400 BCE, and they represent a major philosophical shift in Hinduism. The Upanishads are concerned with the nature of the self, the ultimate reality, and the relationship between the two. They introduce the concept of Brahman, the ultimate reality that underlies all existence, and Atman, the individual self that is identical to Brahman. The Upanishads are a foundational text in Hindu philosophy and have influenced the development of other philosophical traditions, such as Buddhism. Ancient Greece, Plato and Aristotle. In ancient Greece, the philosophy of religion was explored through the works of Plato and Aristotle. Plato's Republic and Phaedo explore the nature of the soul, the immortality of the soul, and the relationship between the soul and the divine. Plato believed that the soul was immortal and that it existed prior to and after physical death. He also believed in the existence of a divine realm, which he called the forms, that was the source of all reality. Aristotle, on the other hand, was more concerned with the nature of the physical world and the relationship between the physical world and the divine. He believed that the universe was eternal and that it was governed by natural laws. He also believed in the existence of a prime mover, a divine being that was responsible for setting the universe in motion. Early Christianity, St. Augustine. In early Christianity, the philosophy of religion was explored through the works of St. Augustine. Augustine's Confessions and City of God are concerned with the nature of God, the problem of evil, and the relationship between humanity and the divine. Augustine believed that God was the source of all existence and that humanity's ultimate goal was to achieve a union with God. He also believed that evil was a result of humanity's separation from God and that the only way to overcome evil was through a deepening of one's relationship with God. Medieval Islam, Al-Ghazali. In medieval Islam, the philosophy of religion was explored through the works of Al-Ghazali. Al-Ghazali's The Incoherence of the Philosophers and the Revival of Religious Sciences are concerned with the relationship between reason and faith, the nature of God, and the afterlife. Al-Ghazali believed that reason was limited and that true knowledge of God could only be obtained through faith and spiritual experience. He also believed in the existence of an afterlife and the importance of moral conduct in achieving a favorable outcome in the afterlife. Renaissance Europe, Thomas Aquinas. In Renaissance Europe, the philosophy of religion was explored through the works of Thomas Aquinas. Aquinas' Summa Theologica is a comprehensive examination of the nature of God, the relationship between humanity and the divine, and the existence of evil. Aquinas believed in the existence of a single, all-powerful God who was the source of all creation. He also believed that humanity's ultimate goal was to achieve a union with God and that this could be accomplished through a life of moral conduct and spiritual contemplation. Modern times, Immanuel Kant and Friedrich Nietzsche. In modern times, the philosophy of religion has been explored through the works of Immanuel Kant and Friedrich Nietzsche. Kant's critique of pure reason and critique of practical reason are concerned with the nature of God, the limits of reason, and the relationship between morality and religion. Kant believed that the existence of God could not be proven through reason alone and that morality was independent of religion. Nietzsche, on the other hand, was a critic of traditional religious beliefs and values. His works, such as Thus Spoke Zarathustra and Beyond Good and Evil, are concerned with the nature of morality, the role of religion in society, and the concept of the will to power. Nietzsche believed that traditional religious beliefs and values were limiting and that humanity needed to embrace a new, more life-affirming philosophy. In conclusion, the philosophy of religion has been explored through the classics of the world's major religious traditions. From the Vedas of ancient India to the works of St. Augustine in early Christianity, the classics of the world have explored the nature of God, the meaning of existence, and the relationship between humanity and the divine. Through the works of Plato, Aristotle, Al-Ghazali, Aquinas, Kant, and Nietzsche, the philosophy of religion has continued to evolve and develop, offering new insights into these timeless questions. The major world religions have spawned remarkable philosophical insights into questions of the divine, faith, and human spirituality. The classics of various religious traditions have grappled with questions about the nature of God, the role of reason. In religious belief, the problem of evil, and the relation between wisdom and faith. Over history, these texts have influenced each other and collectively shaped the development of philosophy of religion as an academic discipline. The Upanishads, ancient Indian texts which form part of the Hindu Vedas, provide some of the earliest philosophical reflections on religion. Dating from around 1200 to 500 BCE, the Upanishads debate concepts such as Atman, the human soul, Brahman, the ultimate spiritual reality, and the relationships between self, world, and God. They pose foundational questions about how to attain spiritual knowledge and liberation that would profoundly influence later philosophers. The mystic insights of the Upanishads especially shaped key Islamic philosophers like Ibn Arabi, who attempted to synthesize Hindu and Islamic religious thought. Similarly, the massive corpus of Buddhist scriptures spanning many centuries contains influential philosophical reflections on the nature of human suffering, the goal of liberation, and the spiritual path. The 4th century Buddha presented epistemological arguments for the non-existence of God and analyzed key religious concepts like karma and rebirth without reference to a divine creator. His skeptical questioning of established beliefs challenged religious authorities while planting seeds for a more reasoned approach to faith. Buddhist philosophy thus contributed to early debates on religious rationality that informed later European thinkers. In the Judeo-Christian tradition, the Bible's notion of a rational creator who reveals truth through divine communication shaped foundational ideas of Western theism. Biblical books like Job, Ecclesiastes, and Psalms wrestled profoundly with the problem of evil and human longing for God. Jewish and early Christian philosophers built on these roots, developing sophisticated theological formulations of God's omnipotence, omniscience, and goodness. Later Christian scholastic philosophers like Aquinas formulated rational proofs for God's existence based on biblical revelation and Aristotelian thought. Extrasolar planets and the possibility of life on them. The search for life beyond our solar system has been a topic of fascination for scientists and the public alike for decades. With the discovery of thousands of exoplanets, planets outside our solar system, in recent years, the possibility of finding life beyond Earth has become an increasingly exciting prospect. One of the primary factors that determine a planet's potential for life is its distance from its host star and the presence of liquid water. The habitable zone, also known as the Goldilocks zone, is the region around a star where conditions are just right for liquid water to exist on the surface of a planet. Planets within the habitable zone have the potential to support life as we know it, although other factors, such as the planet's atmosphere and geology, also play a role. Recent discoveries have shown that planets within the habitable zones of their host stars are more common than previously thought. For example, the TRAPPIST-1 system, located 40 light-years from Earth, contains 7 Earth-sized planets, 3 of which are located within the habitable zone. These planets represent some of the best candidates for the search for life beyond our solar system. The study of exoplanets has also led to the discovery of a wide range of planet types that do not exist in our own solar system, such as super-Earths and mini-Neptunes. Super-Earths are rocky planets that are larger than Earth but smaller than Neptune, while mini-Neptunes are gaseous planets that are smaller than Neptune. These planets have the potential to support life, but their unique characteristics and environments may pose new challenges in the search for extraterrestrial life. In addition to the search for life on exoplanets, scientists are also studying the potential for life on moons and other celestial bodies within our own solar system. For example, Jupiter's moon Europa is believed to have a subsurface ocean of liquid water. And NASA's upcoming Europa Clipper mission aims to study the moon in detail and investigate its potential for life. Another example is Saturn's moon Enceladus, which is believed to have a subsurface ocean and geothermal activity. The Cassini spacecraft, which orbited Saturn from 2004 to 2017, detected plumes of water vapor and other materials erupting from the moon's surface, providing evidence of a subsurface ocean. The discovery of these plumes has led to speculation that Enceladus could harbor life. The search for life beyond our solar system is a complex and challenging endeavor that requires innovative technology and techniques. One of the most promising methods for detecting signs of life on exoplanets is through the study of their atmospheres. The composition of an exoplanet's atmosphere can provide valuable clues about its potential for life. For example, the presence of oxygen, methane, or other organic compounds could indicate the presence of biological activity. Scientists can study an exoplanet's atmosphere by observing the light that passes through it as the planet transits in front of its host star. By analyzing the spectrum of this light, scientists can identify the chemical components of the planet's atmosphere. The study of exoplanet atmospheres has already yielded some exciting results. In 2019, the Hubble Space Telescope detected water vapor in the atmosphere of a potentially habitable exoplanet orbiting a nearby star. The detection of water vapor is a significant finding because it is a key ingredient for life as we know it. In addition to studying exoplanet atmospheres, scientists are also investigating the potential for life in extreme environments. Some microorganisms on Earth are capable of surviving in conditions that were once thought to be uninhabitable, such as in the depths of the ocean or in the hot springs of Yellowstone National Park. These extremophiles are of interest to astrobiologists because they could provide insights into the potential for life on other planets and moons with extreme environments. One example of a potential habitat for extremophiles outside of Earth is the subsurface ocean on Jupiter's moon Europa. The ocean is believed to be in contact with the moon's rocky interior, which could provide a source of energy for microbial life. Scientists are also studying the subsurface oceans of other icy moons in our solar system, such as Enceladus and Ganymede, for signs of life. Another promising approach to the search for life beyond our solar system is the study of exoplanet magnetic fields. Earth's magnetic field plays a crucial role in protecting our planet from the harmful effects of solar wind, charged particles that are ejected from the Sun. Exoplanets with magnetic fields could be better protected from solar wind, making them more conducive to the development and maintenance of life. The study of exoplanet magnetic fields is still in its early stages, but recent discoveries have provided some exciting results. In 2020, a team of astronomers used the Hubble Space Telescope to detect a magnetic field around an exoplanet for the first time. The planet, known as WASP 121b, is a gas giant that is located about 900 light-years from Earth. The detection of a magnetic field on WASP 121b is a significant finding because it suggests that magnetic fields may be more common on exoplanets than previously thought. Another approach to the search for life beyond our solar system is the study of exomoons, moons that orbit exoplanets. Exomoons could provide a habitat for life, and their study could provide valuable insights into the potential for life beyond Earth. However, the detection of exomoons is challenging because they are much smaller than their host planets and are difficult to observe directly. Despite the challenges, some promising candidates for exomoons have been identified. For example, observations of the exoplanet Kepler 1625b suggest that it could have a large exomoon. The study of exomoons is an exciting area of research that could provide valuable insights into the potential for life beyond our solar system. Finally, the study of exoplanets and the search for life beyond Earth have significant implications for our understanding of the universe and our place in it. The discovery of life beyond our planet would be one of the most profound discoveries in human history, and it could transform our understanding of the universe and our place within it. Additionally, the study of exoplanets and the potential for life beyond Earth could inspire new generations of scientists and engineers and lead to technological advancements that benefit society in numerous ways. Another approach to the search for life beyond our solar system is the study of exoplanet geology. The geological processes that shape a planet's surface and interior can provide valuable clues about its potential for life. For example, the presence of volcanoes, tectonic activity, and subsurface oceans could indicate the presence of a habitable environment. The study of exoplanet geology is challenging because it requires detailed observations of a planet's surface and interior. However, recent advances in observational techniques have enabled scientists to study the geology of exoplanets with increasing accuracy. For example, the Transiting Exoplanet Survey Satellite, TESS, is capable of detecting small changes in a star's brightness caused by a planet passing in front of it. These observations can provide valuable insights into a planet's size, mass, and orbit, which can be used to infer its geological properties. In addition to the study of exoplanet geology, scientists are also investigating the potential for life on exoplanets that orbit binary stars, two stars that orbit around a common center of mass. Binary star systems are common in the universe, and the study of exoplanets in these systems could provide valuable insights into the potential for life in unique environments. For example, the planet Tatooine in the Star Wars universe is a fictional example of a planet in a binary star system. Understanding the origin of the universe, explaining the origin of the universe and how it was formed. The origin of the universe has been a topic of great interest and fascination for scientists, astronomers, and cosmologists alike. The study of the origin of the universe, known as cosmology, has led to many groundbreaking discoveries and theories about how the universe came to be. In this article, we will explore the current understanding of the origin of the universe and the various theories proposed to explain its creation. The prevailing theory of the origin of the universe is the Big Bang theory, which proposes that the universe began as a singularity, a point of infinite density and temperature, approximately 13.8 billion years ago. According to this theory, the universe began to expand rapidly in a process called inflation, during which it expanded faster than the speed of light. As the universe expanded, it cooled and matter began to form. The first atoms, hydrogen and helium, were created within the first few minutes of the universe's existence. The evidence for the Big Bang theory is vast and includes the cosmic microwave background radiation, which is the afterglow of the Big Bang that is still visible today. The cosmic microwave background radiation is a uniform, low-level radiation that permeates the entire universe, and is believed to be the residual heat left over from the Big Bang. Another piece of evidence for the Big Bang theory is the abundance of light elements, such as helium and hydrogen, which were created during the early moments of the universe's existence. The Big Bang theory also explains the observed redshift of distant galaxies, which suggests that the universe is expanding. While the Big Bang theory is widely accepted by the scientific community, it is not without its critics. Some scientists propose alternative theories, such as the steady-state theory, which proposes that the universe has always existed, and will continue to exist indefinitely. However, the evidence for the Big Bang theory remains strong, and it is considered the most likely explanation for the origin of the universe. One of the key challenges in understanding the origin of the universe is the question of what caused the Big Bang. Some scientists propose that the Big Bang was the result of a quantum fluctuation in the fabric of space and time. Others suggest that the Big Bang was the result of a collision between two universes, or that it was the result of a collapse of a supermassive star. While there is no consensus on what caused the Big Bang, the current understanding is that it was a singular event that gave rise to the universe as we know it today. In addition to the Big Bang theory, there are other theories that attempt to explain the origin of the universe. One such theory is the cyclic model, which proposes that the universe goes through an infinite cycle of expansion and contraction. Another theory is the ekpyrotic model, which proposes that the universe was created when two higher-dimensional worlds collided. The study of the origin of the universe has led to many fascinating discoveries and has deepened our understanding of the world around us. As scientists continue to study the universe and its origins, it is likely that new theories and discoveries will emerge, leading to even greater insights into the mysteries of the cosmos. The origin of the universe is a topic that has fascinated scientists and philosophers for centuries. While there is still much to learn and discover, current theories and observations have provided insights into how the universe came to be. The prevailing theory about the origin of the universe is the Big Bang theory. According to this theory, the universe began as a singularity, a point of infinite density and temperature. This singularity then rapidly expanded in a massive explosion approximately 13.8 billion years ago. As the universe expanded, it cooled and matter began to form. Evidence for the Big Bang theory comes from a variety of observations, including the cosmic microwave background radiation, the abundance of light elements, and the observed large-scale structure of the universe. These observations provide support for the idea that the universe began in a hot, dense state and has been expanding and cooling ever since. However, the Big Bang theory does not explain everything about the origin of the universe. One of the biggest mysteries is what caused the initial singularity to exist in the first place. Another mystery is why the universe appears to be flat and uniform on a large scale, despite the fact that different regions of the universe are not in causal contact with each other. To try to answer these questions, scientists have proposed several different hypotheses. One such hypothesis is the inflationary theory, which suggests that the universe underwent a brief period of exponential expansion just moments after the Big Bang. This expansion would have smoothed out the initial irregularities and could explain the uniformity of the universe on a large scale. Another theory is the cyclic model, which suggests that the universe goes through an infinite series of cycles, each beginning with a Big Bang and ending with a big crunch, where the universe collapses back in on itself. This theory proposes that the current universe is just one in a long line of universes that have existed and will continue to exist in the future. Despite these unanswered questions, the study of the origin of the universe has led to a greater understanding of the nature of matter, energy, and the laws of physics. It has also led to technological advancements, such as the development of the Hubble Space Telescope, which has allowed us to observe the universe in greater detail than ever before. As we continue to study the universe and its origins, it is likely that new discoveries and insights will emerge. But for now, the Big Bang theory remains the most widely accepted explanation for the origin of the universe. Cosmic microwave background radiation, CMB, is a key piece of evidence for the Big Bang theory of the origin of the universe. This faint, ubiquitous radiation is the afterglow of the hot, dense state that the universe was in just 380,000 years after the Big Bang, when it had cooled enough to become transparent to light. The CMB is present in all directions of the sky and has a nearly uniform temperature of about 2.7 Kelvin, or minus 270.4 degrees Celsius. The discovery of the CMB is attributed to two radio astronomers, Arno Penzias and Robert Wilson, who in 1964 detected a low level of microwave radiation coming from all directions of the sky. They initially believed the signal was the result of pigeon droppings on their antenna, but after thorough cleaning, the signal persisted. At the same time, theoretical physicists Robert Dicke, Jim Peebles, and others were actively searching for evidence of the CMB as a remnant of the Big Bang. When they learned of Penzias and Wilson's discovery, they realized that they had found what they were looking for. The CMB has a nearly perfect blackbody spectrum, meaning that it has a characteristic pattern of radiation that corresponds to a thermal equilibrium at a specific temperature. This pattern is consistent with a prediction of the Big Bang theory that the universe started out in a hot, dense state and has been cooling and expanding ever since. The small variations in temperature of the CMB across the sky provide important information about the distribution of matter and energy in the early universe. These variations are thought to be the seeds that eventually grew into the large-scale structure of the universe we observe today. In addition to confirming the Big Bang theory, the CMB has also been used to study the composition and history of the universe. The uniformity of the CMB's temperature across the sky, for example, provides evidence that the universe is homogeneous and isotropic on large scales.
Space stations and the search for aliens, efforts to find aliens through space stations. Since the first human-made satellite, Sputnik 1, was launched into space in 1957, humanity has been exploring the universe using various spacecraft and space stations. One of the most intriguing aspects of space exploration is the search for extraterrestrial life, and space stations have played a crucial role in this search. The first space station, Salyut 1, was launched by the Soviet Union in 1971. Since then, numerous space stations have been launched by various countries, including the United States, Russia, and China. These space stations have served a variety of purposes, such as scientific research, testing new technologies, and as a staging ground for future space missions. One of the primary goals of space stations is to search for extraterrestrial life. Scientists have been searching for evidence of life beyond Earth for decades, and space stations have been instrumental in this search. One example is the International Space Station, ISS, which has been continuously inhabited since 2000. The ISS has a variety of scientific instruments and equipment that are used to search for signs of life, such as the detection of organic molecules in space. Another example of a space station dedicated to the search for extraterrestrial life is the Terrestrial Planet Finder, TPF, project. The TPF is a proposed mission by NASA to search for Earth-like planets around nearby stars. The mission would involve using a series of telescopes to detect and study the light from these planets, with the goal of detecting signs of life such as the presence of oxygen or other biomarkers. In addition to space stations, spacecraft such as the Kepler Space Telescope and the Transiting Exoplanet Survey Satellite, TESS, have also been used to search for extraterrestrial life. These spacecraft have been instrumental in detecting thousands of exoplanets, or planets outside our solar system. Scientists are studying these exoplanets to determine if they could potentially support life. The search for extraterrestrial life is ongoing, and space stations and spacecraft continue to play a crucial role in this search. As technology advances and our understanding of the universe grows, it is possible that we may one day discover evidence of life beyond Earth. In conclusion, space stations and spacecraft have been instrumental in the search for extraterrestrial life. These facilities have provided scientists with the tools and resources needed to search for signs of life beyond Earth, and have detected numerous exoplanets that could potentially support life. The search for extraterrestrial life is ongoing, and as technology continues to advance, we may one day discover evidence of life beyond our planet. The search for extraterrestrial life is a fascinating topic that has captured the imagination of people for generations. The possibility of life beyond Earth raises questions about the nature of our existence and our place in the universe. In recent years, advancements in technology have allowed us to explore the cosmos more thoroughly than ever before. And the search for extraterrestrial life has become a major focus of scientific research. One of the key ways that scientists are searching for extraterrestrial life is through the use of radio telescopes. Radio telescopes are used to detect radio signals from space, and scientists believe that these signals could be evidence of intelligent life beyond Earth. The Search for Extraterrestrial Intelligence (SETI) program, for example, uses radio telescopes to scan the skies for signs of intelligent life. Another way that scientists are searching for extraterrestrial life is by exploring other planets and moons in our own solar system. The Mars rovers, for example, have been exploring the surface of Mars for years, looking for signs of past or present microbial life. The upcoming Europa Clipper mission will explore Jupiter's moon Europa, which is believed to have a subsurface ocean that could potentially support life. In addition to searching for signs of life, scientists are also exploring the conditions that are necessary for life to exist. The field of astrobiology studies the origins, evolution, distribution, and future of life in the universe. Astrobiologists study the conditions that are necessary for life to exist, such as the presence of liquid water and organic molecules, and use this information to identify planets and moons that could potentially support life. Despite decades of searching, we have yet to discover definitive evidence of extraterrestrial life. However, scientists remain optimistic that we will one day find evidence of life beyond Earth. With continued advancements in technology and our understanding of the universe, the search for extraterrestrial life is sure to continue for many years to come. In conclusion, the search for extraterrestrial life is a complex and ongoing endeavor that involves a variety of scientific disciplines and technologies. Scientists are exploring the cosmos using radio telescopes, spacecraft, and rovers to search for signs of life and study the conditions necessary for life to exist. While we have yet to discover definitive evidence of extraterrestrial life, the search continues to capture the imagination of people around the world. The possibility of discovering life beyond Earth is an exciting prospect that has the potential to revolutionize our understanding of the universe and our place in it. The search for extraterrestrial life is not only a scientific pursuit but also a philosophical one. The question of whether we are alone in the universe has profound implications for our understanding of our place in the cosmos and our relationship with other life forms. The search for extraterrestrial life has also led to new insights and discoveries in fields such as astrobiology, planetary science, and astronomy. One of the most significant discoveries in recent years has been the discovery of exoplanets, planets that orbit stars other than our Sun. With the help of powerful telescopes such as NASA's Kepler and TESS missions, astronomers have discovered thousands of exoplanets, many of which are located in the habitable zone, the region around a star where temperatures are just right for liquid water to exist. The discovery of these exoplanets has renewed hope that we may one day discover life beyond Earth. Another promising avenue of research is the study of extremophiles, organisms that can survive in extreme environments on Earth, such as deep-sea hydrothermal vents or polar ice caps. By studying these organisms, astrobiologists hope to gain insights into the conditions that are necessary for life to exist and potentially discover new forms of life in the universe. The search for extraterrestrial life has also led to the development of new technologies and techniques for exploring the cosmos. For example, the James Webb Space Telescope, set to launch in 2021, will be the largest and most powerful space telescope ever built. With the ability to peer back in time to the early universe and study the atmospheres of exoplanets. Other technologies being developed include laser communications, which could allow us to send and receive signals from spacecraft much faster than current radio technology. Despite the many advancements and discoveries in the search for extraterrestrial life, the question of whether we are alone in the universe remains unanswered. It is possible that we may never discover definitive evidence of extraterrestrial life, or that it may be vastly different from anything we can currently imagine. However, the search for extraterrestrial life continues to drive scientific curiosity and inspire new generations of researchers and explorers. In conclusion, the search for extraterrestrial life is a multifaceted pursuit that involves a range of scientific disciplines and technologies. From the discovery of exoplanets to the study of extremophiles, the search for extraterrestrial life has led to new discoveries and insights in fields such as astrobiology. Formation of celestial bodies in space. Explain how celestial bodies in space were formed and developed. The formation of celestial objects in space is a complex and ongoing process that has been the subject of study and speculation for centuries. From stars and planets to asteroids and comets, the universe is home to a wide variety of celestial objects that have unique origins and characteristics. One of the most fundamental processes in the formation of celestial objects is the collapse of interstellar gas and dust clouds. These clouds are composed of mostly hydrogen and helium, along with trace amounts of heavier elements, and can span many light-years in size. As these clouds collapse under the force of gravity, they begin to spin and flatten into a disk-like structure known as a protoplanetary disk. Within these disks, the gas and dust begin to clump together and form larger and larger objects through a process known as accretion. Over time, these objects can grow into planetesimals, which are small, rocky bodies that can range in size from a few meters to several kilometers in diameter. Some planetesimals may continue to grow and eventually become planets, while others may remain relatively small and become asteroids or comets. The process of planetary formation is complex and can take millions or even billions of years to complete. It is influenced by a number of factors, including the composition of the protoplanetary disk, the distance from the central star, and the presence of other celestial objects in the vicinity. In addition to the formation of planets and asteroids, the universe is also home to a wide variety of other celestial objects that have unique origins and characteristics. These include stars, which form through a similar process of gas and dust collapse, as well as black holes, neutron stars, and other exotic objects that are formed through the collapse of massive stars. In conclusion, the formation of celestial objects in space is a complex and ongoing process that is shaped by a variety of factors, including the composition of interstellar gas and dust clouds, the presence of protoplanetary disks, and the gravitational interactions between celestial objects. By studying these processes and the objects they produce, scientists can gain a better understanding of the universe and our place within it. One of the most fascinating aspects of the formation of celestial objects is the wide variety of shapes, sizes, and compositions that they can take on. For example, the gas giants in our solar system, such as Jupiter and Saturn, are vastly different in size and composition from the small, rocky planets like Earth and Mars. The composition of celestial objects is largely determined by the composition of the protoplanetary disk from which they formed. For example, planets that form closer to the central star tend to be smaller and composed mainly of rock and metal, while planets that form farther out tend to be larger and composed mainly of gas and ice. The formation of celestial objects can also be influenced by the gravitational interactions between objects in the protoplanetary disk. For example, large gas giants like Jupiter can exert a strong gravitational pull on smaller objects in the disk, either flinging them out of the system altogether or causing them to collide and merge together. In addition to these factors, the formation of celestial objects can also be influenced by outside forces, such as collisions with other objects or the presence of nearby stars. These factors can cause disruptions in the protoplanetary disk and lead to the formation of unique and unusual celestial objects. The study of the formation and evolution of celestial objects is a fascinating and ongoing area of research that has the potential to unlock many secrets about the universe and our place within it. By studying the processes that shape celestial objects, scientists can gain a better understanding of the physical laws that govern the cosmos and the conditions that are necessary for life to emerge and thrive. In conclusion, the formation of celestial objects in space is a fascinating and complex process that is influenced by a wide variety of factors, including the composition of interstellar gas and dust clouds, the presence of protoplanetary disks, and gravitational interactions between celestial objects. By studying the formation and evolution of these objects, scientists can gain a deeper understanding of the universe and the conditions that make life possible. One of the most exciting areas of research in the study of celestial object formation is the search for exoplanets, or planets that orbit stars other than our own Sun. With the discovery of thousands of exoplanets in recent years, scientists are gaining a better understanding of the diversity of planetary systems and the conditions that are necessary for life to emerge. The study of exoplanets has also led to the discovery of many strange and unusual planetary systems that challenge our understanding of how celestial objects form and evolve. For example, some exoplanets have been discovered that orbit 2 or even 3 stars, while others have been found that are incredibly dense or have extreme orbital patterns. The formation of celestial objects is not limited to planets and stars. Other objects in the universe, such as asteroids, comets, and moons, also have unique origins and characteristics that are shaped by the same physical processes that govern the formation of planets and stars. For example, asteroids are thought to be remnants of the protoplanetary disk that were not able to accrete into planets. Comets, on the other hand, are thought to be made up of ice and other volatile materials that were able to survive in the cold outer reaches of the solar system. The study of celestial object formation has many practical applications, including the search for habitable exoplanets and the exploration of our own solar system. By understanding how celestial objects form and evolve, scientists can develop new technologies and techniques that allow us to explore these objects in greater detail and gain a deeper understanding of the universe and our place within it. In conclusion, the formation of celestial objects in space is a fascinating and complex process that is shaped by a wide variety of factors. Through the study of celestial object formation, scientists are gaining a better understanding of the physical laws that govern the universe and the conditions that are necessary for life to emerge and thrive. With new advances in technology and a growing interest in the exploration of the cosmos, the study of celestial object formation is likely to remain a vibrant and exciting area of research for many years to come. Over the past few decades, astronomers have developed new techniques for studying protoplanetary disks in greater detail, including using telescopes that can observe at infrared and millimeter wavelengths. These observations have led to many new discoveries, including the detection of gaps and rings in protoplanetary disks that are thought to be caused by the formation of planets. The study of protoplanetary disks has also led to new insights into the physical processes that govern the formation of celestial objects, including the role of magnetic fields, turbulence, and other factors. By studying the structure and composition of protoplanetary disks, scientists can develop new models and simulations that allow us to better understand how celestial objects form and evolve. In addition to the study of protoplanetary disks, the study of celestial object formation also has important implications for the search for life beyond Earth. By understanding the conditions that are necessary for the formation of habitable planets and the emergence of life, Scientists can better target their search for habitable exoplanets and develop new technologies and techniques for detecting signs of life beyond our solar system.